Hi, my name is Juan Pablo Espinola Rosas, and our team is conformed by Alejandro Espinola, Axel Ivan Vasquez, and Juan Pablo Hernandez, and we are going to present our K activity final stage.
Well, first, our research question was: is the time for when both cars have the same position calculated with a stopwatch different or equal to when using physics formulas? Well, the idea for the experiment is to observe the time that it takes for some prototype car to reach another, using the experiment to acquire the time in which both cars have equal positions. The same velocity will be using physics formulas to obtain the time at which they will have the same position. With this, the times can be compared, one obtained at the experiment and the other with the formulas, and determine if they are the same or different. It is pertinent because it can prove the accuracy of using procedures to reach the result versus collecting them in real time. Then we have the theoretical framework. And well, kinematics is the study of the motion of points, objects, and groups of objects without considering the causes of its motion, and can also be defined by the branch of mechanics concerned with objects in motion, but not with the forces involved. So, well, objects are in motion all around us. Everything from a tennis match to a space-proof flyby of the planet Neptune involves motion. When you are resting, your heart moves blood through your veins. Even in inanimate objects, there is continuous motion in the vibrations of atoms and molecules. A formal study of physics begins with kinematics. The word kinematics comes from a Greek word kinesis, meaning motion, and is related to other English words such as cinema, movies, and kinesiology, the study of human motion. To describe motion, kinematics studies the trajectories of points, lines, and other geometric objects. Also, the study of kinematics can be abstracted into purely mathematical expressions, and kinematic equations can be used to calculate various aspects of motion, such as velocity, acceleration, displacement, and time.
For this experiment, we found the stored variables, which are three of them. We have the first one is the independent variable, the one that is altered during the experiment, is the distance between both cars at the beginning. Then we have the dependent variable, the one being measured during the experiment, is the time in which the cars will be at the same position. The controlled variable, which affects the outcome of the experiment and must be kept equal to obtain trustworthy results, will be the car's shape and material, their velocity, and the surface in which they will run, to assure the friction existing between the material of the floor's surface and the tires won't change. In order to complete this experiment, we need several materials, such as two toy cars, a stopwatch, a measuring tape, and a sheet of paper or document to record the results.
Well, here we have the data that we use for the experiment. To start, there will be two cars, 1 meter apart, one from each other, and it will be calculated at what time they are going to collide. First, both cars will be collided, one on minus 0.5 meters and the other on 0.5 meters. There will have to be some signs to know where the cars were at the beginning and where they're gonna end. Once everything is in position, the cars will be starting to move, and in order to calculate the time, we are going to use a stopwatch. When the cars collide, it will be needed to take measures from where the cars started to where they collided. Then, the equations will be used to verify that the time calculated with kinematic equations is the same or approximated to the time calculated with a stopwatch. Well, here at the right, we can see the specific data of the cars, like the initial position, initial velocity, acceleration, velocity, final position, and time for impact. Here we have all the procedures and all the equations that we use to calculate all the data. For example, the velocity of the impact, or the acceleration that the car had before it collide, and also the equations for the time and the final distance.
And finally, as well, like the slide of Axel, here we can see the formulas that we use in the experiment, and with all of this, well, it can be proved where the time calculated with a stopwatch is the same when using kinematic equations. And finally, with all the knowledge acquired during the course, is how we could be able to calculate this experiment, because in order to solve this, we need to take hand of the kinematic equations and the variables. Maybe in real life situation, we won't sit down to calculate the velocity and acceleration on a car that we saw, but these kinematics, we are going to use them for other things, and we won't even realize we are applying them in our problems. And that is the biggest learning we take from this key activity and from the entire course. Thank you.
Thank you very
Thank you.
much.
Thank you very much.